full alpha test for which expected value of phi x is strictly less than alpha. Now, the intuition suggests that in normal circumstances, that should not be possible. So that means if you have to find an example, you have to be crazy, right? Because that would be more for your own satisfaction that, look, I have found an example, but it may not be of practical interest because my practical considerations demand that such a test will not exist, right? Because I can always play around. If it is less than alpha, I'll construct another test for which I use more liberty to reach it to alpha. Then the probability of type 2 error further I can minimize. So that means there will be a situation which will be a trivial kind of a situation where that can happen. So let us consider one such situation. So the situation is as follows. Suppose X is a single observation. I'm just trying to test it based on a single observation. Uniform theta, theta plus 1. Right? My H0 is theta is equal to 0 against H1 that theta is equal to 1. All right. So what does theta is equal to 0 corresponds to? That means your distribution is uniform 0, 1. What is the distribution under theta is equal to 1? Uniform 1, 2. Now I would ask you to use your statistical mind to test this hypothesis. There's nothing very great about it. Just use your common sense. You don't need anything else. You say it says under H0 your support is 0, 1. Under H1 support is 1, 2. So if you're observing X and X lies between 1 to 2, you reject. Right? That looks like a trivial test. That would be the best test one can consider. Right? But let us see what does the Neyman-Paerson lemma says. So let us consider delta X, which is F1X minus C times F0X. Right? Let us see what is my F0X. F0X is uniform 0, 1. So that is 1 if 0 less than X less than 1. F1X is 2 minus 1, 1 if X is between 1 to 2. All right. So let's see what is delta X, which is F1X minus F0. So my support is 0 to 1, union 1 to 2. So that means my support is 0 to 2. So I should only consider values which lie between 0 to 2. So if I consider this, if X is between 0 to 1, what is my F1X? 0. So it is minus C times F0X. Minus C, just C. When X is between 1 to 2, it is 1. So what does my Neyman-Paerson lemma says? This is the reason I cannot here F1X minus C times F0X is positive. So I cannot do anything about it. Here my phi X has to be 1. Phi X is 1, that means reject H0 with probability 1 if X is between 1 to 2. And that is what your common sense demanded, right? Because you would reject if X is between 1 to 2, there is no scope then that H0 can be true because H0 has a support 0 to 1. So in this case, my phi X has to be 1. But in this case, depending on C, I can play around. So one choice is C is strictly positive because C has to be greater than or equal to 0. That I know. Suppose C is strictly positive. Right? So case first, C is strictly positive. Then in this case, it is negative. Then in this case, that means phi star X is 1 if X is between 1 to 2 and 0 if X is between 0 to 1. All right? There is no constant to determine over here. So it would have a fixed level. So let's consider what is its E theta 0 of phi X. because there is no constant to control level of significance. What is E theta 0 phi x? Under H naught, probability that x lies between 1 to 2. And what would be that? That would be 0. So certainly this test would be uniformly most powerful test if my level is 0. And that is the best scenario one can think of, right? What is the power of this test? This would be rejecting H naught when H1 is 2. Under H1, X is uniform 1, 2. Probability that X lies between 1 to 2 is 1. It's very rosy kind of a situation, right? Type 1 error is minimum, power is maximum. And that is understandable, right? Why understandable? Because your problem is trivial. You don't need statistics to solve this problem. Because it says that under H naught, X would be between 0 to 1. Under H1, X would be between 1 to 2. So if you observe that X is lying between 1 to 2, you reject H. So this is certainly UMP alpha test if your level is alpha. Now the question is, now let's look at if your level is alpha, can I get more other tests? Because what does it say? Level is alpha, you can play around up to until alpha. So there is a possibility that there may be some other tests, right? So let us look at case 2 when C is 0. If C is 0, that means here I have a C0. So this is a reason where F1x is same times C times F0x. So here I can put this as gamma. So my phi star x is gamma if x lies between 0 to 1 and 1 if x lies between 1 to 2. I want to choose gamma such that E theta phi x is between 0 to 1, right? So E theta 1 phi star x I want should be less than or equal to alpha, right? That is how the gamma has to be chosen. Theta 0. What does that mean? That means gamma times probability under H naught, because under H naught x lies between 0 to 1, so this probability would be 1. Right? So that means gamma should be less than or equal to alpha. Okay. So many tests you get. Gamma less than or equal to any choice of gamma less than or equal to alpha. And you can test, find that any choice between gamma to alpha would give you power of the test to be 1. So choose any gamma, in fact, between 0 to 1 will give you. Right? Because that is the only requirement I have. What is the power of such test? It will be gamma times P theta 1, that x between 0 to 1, plus P theta 1, that 1 is between x to 2. What is this probability? 0, right? Because under H1, which is theta 1, which is 1, you have a uniform 1 to 2. So 0, this probability is 0. And what is this probability? So power of all these tests is 1 again. So you have infinitely many most powerful alpha tests. So this is one situation where you have infinitely many most powerful tests. Not only that, here E theta 1 phi x is less than or equal to alpha, can be strictly less than alpha. right? Alpha may be prescribed. Any gamma less than or equal to alpha will give you this thing, and for that, E theta 1 phi x would be exactly alpha. So if you look at what is E theta 1 phi star x in this situation, which may not be alpha, right? It's less than. But you see, in normal circumstances, I would not have given this example, but it's very essential to understand what Neyman Paerson lemma says. Right? For that understanding, this example is essential. That you can have what? You see, here I argue, here I'm saying any such test would be MP alpha. You take choice of gamma is any gamma less than or equal to, right? That is what I conclude. Then I try to look at, if I look at any such test, what would be its size? E theta 1 phi star x. E theta 1 phi star x is gamma, right? In this case, expected under phi star x is gamma, which is gamma times probability x lies between 0 to 1. This is gamma. And how I have chosen my gamma? Any gamma less than or equal to alpha would do. So essentially speaking, you can choose gamma such that it is strictly less than alpha. So you have MP alpha test for which E theta 1 phi star x can be strictly less than alpha. The purpose was considering this example was exactly that. Yeah, sorry, it should be theta naught. You're right. Other tests are there, right? Because you see that I'm using now past, you see when I'm looking at this gamma, I'm using the part 2. Neyman Paerson lemma says these are the choices, right? Depending on what your C is. So I'm applying the Neyman Paerson lemma, C could be positive, less than 0. So if C is, I look at C is positive, then I look at the only value of alpha which is possible is 0. So if alpha is given to be greater than 0, this choice will not work. C is greater than 0 will not. In that case, I have to come over here. It says, if you apply the first part, it says you choose gamma to be alpha. That is the first part gives. But when I look at the second part, it says that if you look at any MP alpha test, that would be of this type. They can differ where f1x is same as C times f0x. That is the reason x between 0 to 1. And I'm trying to see over there what is happening. Okay. Now, I would say that try to apply your statistical mind a little bit over here. It tells you a lot of statistics. If you have a statistical mind, you can use it over here. Because a lot of times students complain that I don't see an application of this. Application will not come. Somebody will not give you a Divya Shakti that you can throw it. You have to use your Divya Shakti, right? Try to use it over here. Now, my question is, among all these tests, which test would we prefer? You have got infinitely many MP alpha tests, right? You have got, you're dealing with a situation where you have got infinitely many MP alpha tests. Which one would you prefer? Use your mind, use your statistical mind. Which one? But I don't know that you're telling theoretically. I have given you infinitely many tests. Tell me among all these tests which are written in blackboard or a green board, which one would you prefer? Case 1, right? And that is what your common sense says, right? Because although all those tests are MP alpha test, they said you can go up to probability of type 1 error up to alpha. It says among all these tests are MP alpha, but for that test, probability of type 1 error is also minimum, which is 0. Right? So among all these tests, you would prefer that test, and that test was nothing but your common sense, right? Because in this case, this was a trivial kind of an example where under H0, x was between 0 to 1, under H1, x was between 1 to 2. So why use statistics? Any layman would say that reject H0 if x lies between 1 to 2. in this case, it is possible to minimize both the errors simultaneously. I can make both the errors 0. It is because it is a trivial kind of a scenario, right, where you don't need any statistics. I'm saying if you require a statistic, then it is not possible to minimize both kind of errors. This kind of here you don't need statistics. It says one is coming from a country which has its own distinct features, and one is coming from another country which has its own distinct feature. He says, I'll give you an individual. Tell me whether he's from this country or that country. So there's no scope of messing up over here, because in one case range is between 0 to 1, and in one case you know that whatever you observe would be between 1 to 2. So once you observe, if you observe 0.5, suddenly H1 cannot be true, probability 1. Right. So here with certainty everything is happening, right? With certainty either H0 is true, or with certainty H1 is true, because the supports are non-overlapping. So yes, this is a situation where both the errors can be minimized simultaneously. And reason is very simple, because it's kind of a situation where statistics plays no role. So wherever there is some amount of randomness involved, that is a situation where, and that is a norm, those would be normal kind of a situation. This is a abnormal situation which has been artificially created by me. Right? Just to tell you, just to get a more insight into what Neyman-Paerson lemma says. Is that okay? Any questions on this? Okay, so let's move further. I have given you homework, a lot of problems. There is a problem of testing normality against Cauchy distribution, right? So there's a question which says that X is a simple observation which has density F. You have to test H0 that Fx is equal to 1 by root 2 pi e to power minus x square by 2. H1 that F is Cauchy, which is 1 by pi right? Find note that I've told you that wherever the supports under H0 and H1 are same, it's easier to deal with F1x upon F0x, because there is no situation like a 0 by infinity, 0 by some positive quantity or positive by 0, right? Unlike it is happening in the uniform case. So wherever supports are the same under H0 and F1, you can deal with F1x upon F0x, because then saying that F1x by F0x is greater than C is just studying the behavior, right, of the function F1x by F0x. So in this case, you can consider F1x by F0x. What would be this? This would be some constant, right? And then e to power x square by 2 upon 1 plus x square, right? Is that okay? No, you can study this as a behavior of x square. Now this would be greater than k. Suppose this turns out to be increasing function, this greater than k, you can study and then determine the critical. So I have given this as a homework problem. Try to do that. Let us consider another example. Let me check what example I have given in the notes. I have solved this problem by the way, in my lecture notes also. So you can see those lecture notes. Okay, so now let us consider this problem. X1, X2, Xn are IID binomial. Let us say 1 theta. Theta 0 and theta 1 are fixed constants such that theta 1 is greater than theta 0. So these are fixed constants. All right, suppose you have to test H naught when theta is equal to theta 0 against theta is equal to theta 1. Right? Now here also I know that my support is same. It would be x size between 0 to 1, right? So for x, which is x1, x2, xn, find MP alpha test. So for x, which is x1, x2, xn, belonging to each xi can belong to only 0, 1, right? So this is n-fold Cartesian product of the set 0 to 1. I look at what is my f theta x? If I try to look at under theta, it is a binomial 1 theta, so it would be theta to power summation xi 1 minus theta to power n minus summation xi, which is same as theta upon 1 minus theta to power summation xi and 1 minus theta to power n. Okay. Now, my Neyman and Paerson lemma says that I can find one MP alpha test, says that f1x upon f0x is greater than c, right? That would be 1 if f1x upon f0x is greater than c. Here support is same, so f1x minus c times f0x is positive, is equivalent saying that f1x upon f0x is greater than c, right? Your supports are same. So let's look at what is f theta 1x upon f theta 0x. That is theta 1 into theta 1 minus theta naught, right? Divided by theta naught into 1 minus theta 1 to power summation xi, right? And then 1 minus theta 1 to power n upon 1 minus theta naught to power n. Is that okay? Let us look at Lemma-Paerson lemma. Everything depends on whether this quantity is bigger than c, greater than c, or is equal to c. When does this happen? So that means this quantity is bigger than c. Okay? Now note that theta 1 and theta naught are fixed constants between 0 and 1. So this is positive quantity. So this is bigger than c is equivalent to saying that this quantity is bigger than some other quantity c1. Because if finally this c1 has to be determined, right? So with respect to level. So I don't bother about what that constant is, because finally that would be determined through alpha. So this is bigger than c1 because this is positive, so inequality doesn't change. Now I have to look at this. So what I do is I take the log both the sides. That will be summation xi log of this. That creates no problem because it is positive. So that is summation xi log of this is greater than log of c. But when I take log of this on that side, the inequality may change, may not change, depending on whether log of this quantity is positive or negative. So I see when this is positive, right? That this is positive, that means this would be bigger than 1. Log of this would be positive, that means this is bigger than 1. Then the equality doesn't change. It will be some other constant, summation xi bigger than some other constant, c2. This is bigger than 1 or less than 1. Theta 1 is given to be bigger than theta naught. So you see theta 1 minus theta naught minus theta 1, theta naught. Theta 1 is bigger than theta naught, so this quantity would be bigger than 1. So the inequality is not going to change. So this is equivalent to saying that summation xi is greater than some constant d. Is that okay? Some other constant d. Now note that if here you have to test h naught theta is equal to theta naught against theta is equal to theta 1, where theta 1 was less than theta naught, then this quantity would have been less than 1, and log of that, and then the equality would have changed your rejection. This region would have been same as summation xi less than d. Is that okay? So that is where whether critical region would be summation xi greater than d, less than d plays a role. Is that okay? Depending on under alternative hypothesis, the theta 1 which you have prescribed is bigger than theta naught or less than theta naught. Okay, so by UMP alpha, by Neyman Paerson lemma, my test is 1 if summation I is equal to 1 to n xi is greater than d, gamma and 0 and this E theta naught phi star should be same as alpha. Should be same as exactly alpha. So what does that mean? That means probability under H naught plus gamma times is that okay? Okay. Now let's try to see if this is okay. This is alpha. Gamma has to be greater than or equal to 0. This probability is greater than or equal to 0. That means this quantity has to be less than or equal to alpha. Right? Because this is positive. When you add some positive, then you get alpha. So this quantity has to be less than or equal to alpha. Right? Now there is a possibility that you have a d such that this is exactly equal to alpha. You can find a d such that this is exactly equal to alpha. In that case, you take gamma to be 0, right? So I consider case 1. There exists a d naught such that probability under H naught is greater than d naught is alpha. So what is your UMP alpha test in this case? Phi star x. So of course this d naught has to be integer, right? I'll take d naught to be an integer, right? Otherwise, so this would be 1 if summation I is equal to 1 to n xi is greater than d naught, and 0 now note that without loss of generality I should take d naught to be integer, because if d naught is not an integer, that test would be same as, for example, suppose this d naught turns out to be greater than 3/2. So your test is 1 if summation xi greater than 3/2, 0 if summation xi less than or equal to 3/2. But that test is equivalent to saying that summation xi is greater than or equal to 2 and less than 2, right? That is what. So what I mean to say is those I need not bother. So I'll take always d naught to be integer. Second case is there is no d naught, such that this is exactly alpha, right? There is no d naught, such that case 1 holds. Then how do you determine this d? there does not exist D. Then this quantity has to be less than or equal to alpha. Right? Note that when D is infinity, when D is n, let us say, what is this probability? 0. So you start from n you know it is less than or equal to alpha. I go to the second level and I see until what stage I do not cross alpha. I can keep on, I start with n. With n, I know that this is 0. I go to n minus 1. If it is still less than or equal to alpha, I go to n minus 2. And so on. And if, let us say, after n minus 2, in the next stage, it crosses alpha, then I take D to be n minus 1, and then I can determine gamma from it. That is how you do that. Okay. Now, so they will exist, find D1 such that probability under theta naught summation I is equal to 1 to n xi is greater than D1 is greater than D1 is less than alpha, but probability that theta naught summation I is equal to 1 to n xi greater than D1 plus 1 bigger more than alpha. Exactly, there is no exactly alpha is not possible because that is the case 2. Is that okay? Now what would be my D in this case? Take D to be D1 because it is less than alpha. Next stage I know that it crosses alpha. So that I cannot take. So take D is equal to D1. And what would be your gamma? Gamma would be alpha minus probability under summation xi is equal to D1. Divided by, sorry, not alpha minus summation xi greater than D1. So this is strictly less than D1, so gamma is positive, and divided by summation xi is equal to p theta naught. And you can see this gamma is between 0 to 1. Gamma is between 0 to 1. Why? Because this alpha is less than or equal to 1, which is 1 minus this, and 1 minus this is same as probability of that. So it has to be less than or equal to alpha, and greater than 0 is clearly possible because the way you have chosen D1. Is that clear? So gamma has to be 0 to 1. Now again, note that I've been saying that try to read what your Neyman-Paerson lemma says. Even in this case, Neyman-Paerson lemma is speaking a lot. I was interested in testing h naught theta is equal to theta naught against theta is equal to theta 1, where theta 1 was bigger than theta naught. Right? Now I change my hypothesis. Suppose my hypothesis becomes h naught at theta is equal to theta naught against theta bigger than theta naught. Find MP alpha test. Can anyone suggest what would be the MP alpha test? Because Neyman-Paerson lemma only talked about testing simple versus simple. Now I have posed a problem that you are testing simple versus composite. So what would be the MP alpha test? Which test? Same test. Why it would be the same test? So let us look at Neyman-Paerson lemma, what it is doing. Once you try to understand that, what it says, I'm testing theta is equal to theta naught against theta is equal to theta 1. Level is controlled only through theta naught. So that will not play because my H naught is same. So that will not. The only thing is whether power is making a. So it says you choose any theta 1 greater than theta naught. This is the uniformly most powerful test. Does it depend on the choice of theta 1? It says power at theta 1 would be larger among all such tests for which E theta naught phi is less than or equal to alpha. That is what testing was. Now, when I look at this test depends on the choice of D, gamma, and Z. D and gamma, right? There's nothing else in this test because observations would be given to you. And how these D and gamma are chosen? They are chosen what theta naught was. And my theta naught is still fixed. So irrespective of what theta 1 you take, as long as it is bigger than theta naught, your power would be maximum. So at each of these points bigger than theta naught, the same test would have the maximum power. And test is not depending on theta 1, which theta 1 you have chosen. So the same test would be most powerful. So phi star is most powerful. The reason is because the test does not depend on the point in the alternative hypothesis which you have chosen. Okay, now I go one step further. So this first H naught, that theta less than or equal to theta naught against theta greater than theta naught. Yeah? Why it will be the same? No. But then there is a possibility that there may be some test because now you need E theta phi x would be less than or equal to alpha for all theta less than or equal to theta. So power is taken care of that by that. But how do you take care of that E theta phi x would be less than or equal to alpha for every theta less than theta naught? Because that is what you want, na, here. Type 1 error should be less than or equal to alpha. Now type 1 error depends on which point in H naught you have chosen. So yes, you're right. The same test would be MP alpha provided the level alpha is satisfied. That means theta phi star x should be less than or equal to alpha for every theta less than or equal to theta naught. Or equivalent to saying that whether supremum over expected value of phi x for theta less than or equal to theta naught is attained at theta equal to theta naught or not. Because in that case, you know that it is exactly alpha. So the question boils down to answering is whether supremum of theta less than or equal to theta naught E theta phi x is same as E theta naught phi x or not, right? Phi star. Is that okay? Why this? Because what you want that my E theta, the same test, because power is taken care of because alternative I'm not changing over here. So power at each of these theta greater than theta naught is maximum for that, but the only thing is whether it has level alpha or not. So for level to be alpha, E theta phi star x should be less than or equal to alpha for every theta less than or equal to theta naught. For every theta, that is what is a requirement. Then only you can say that, then it would meet what you want. Which is equivalent to saying that the maximum of theta less than or equal to theta naught of A theta phi star x would be less than or equal to alpha. In mathematics, a loose term for maximum is a supremum. So that means supremum 0 less than theta less than or equal to theta naught of expected value of phi star x. If that turns out to be E theta naught of phi star x, because for that test, E theta naught phi star x is exactly alpha. Then I'm done. So now I pose you a question on what basis you said that the same test would be this, because I have not shown. I've just simplified your problem. I've said that if this happens, then you can say that. Does this happen? The answer is yes. We'll see that later. that in this case, actually this E theta phi star x, in fact, is an increasing function of theta. So supremum would be attained when theta is equal to theta naught. And which is exactly. Is that okay? So you see, again, Neyman Pearson lemma is telling you a lot of things. That you can even get the uniformly most powerful test for composite hypothesis by just intelligently using the Neyman Pearson lemma. All right? Okay, so let me just stop over here. We'll meet on Thursday. लॉग आउट कर दीजिएगा फेसबुक से. Somebody wanted to discuss, right? Sagun wanted